and for our amount that we need. Okay, and then the calculator is going to go through and do that work for us so that we don't have to type in all of those options that we need, them multiplying times for us. Okay, today it's going to be really important that we use our Desmos calculator because that way we just all have the same format and it's easier to see. You guys all have Desmos on your phones. Not on your phones, I lied, on your computers. Okay, to get to this NPR, the way that we do this is we go to this func, F-U-N-C, and then down in the bottom corner there's this NPR and NCR. Today we're going to do P for permutations, so NPR. We're going to go back to the main menu up here, and then we type in our number. So in our digits this morning, how many digits did we have to choose from? 10. And how many digits were we taking out of the 10? 5. So 10 comma 5, and it tells us our answer is 30,240. So did we get the same answer? Yeah. Yep. It's just we don't have to type in 10 times 9 times 8 times 7 times 6. Because it's nice to go through a little bit like some pain and then save you from your rescuing. You know. Alright, so we're going to do 2 examples with this. We're going to do some probabilities with this today. But in step number 1, we're going to pretend that we are at a swim meet. Okay, and at a swim meet, we're going to have 5 swimmers from Apollo. We're going to have 3 swimmers and 7 swimmers from Sartell. Now, generally speaking, when we talk about swim meets, is it just a random placing, like people just jump in the water and they randomly finish? No, it's based more on ability, but today when we talk about probability, we're going to just say if it's random, okay? Thinking that, like, we're not actually considering who's swimming, who's doing it if they're not good, how many years they've been swimming. We're not going to factor in anything other than just like we're picking it out of a hat, okay? We want to know how many ways can there be to place first, second, and third. So for our permutations, we really just need to know 2 numbers. Okay? Our first number, n, is our total objects. So how many is our total number of swimmers we have? Mm-hmm. 15, 5 plus 3 plus 7. So we have 15 swimmers. And then our r, I should have done a lowercase n, sorry, is how many spots do we care about, of how many places are we going out to? So are we doing all the total ways that they can finish or just a certain amount? Yeah, how many are we caring about? 3. So what we're going to do is in our calculator, we're going to use that NPR function, so lowercase n, capitalized P, lowercase r. And in parentheses, we're going to first list how many we're picking from. So how many swimmers do we have to choose from? 15, and we're going to choose 3. And that's actually the way that we say it. We say a permutation of 15, choose 3. We're picking 3, and that's how much we're choosing. Okay? And then when you do that in our calculator, so again, in the calculator, we're going to go to FUNC. It's this function button at the top. It goes main ABC func. Okay, down at the bottom is this NPR 15, comma 3. And we get 2,730. So there's 2,700. try this again. Numbers are hard. 2,730. It's a hard number to say, apparently. Place first, second, and third. Now, I want to know what is the probability. So I'm going to use just a capital P for probability. That Apollo places first and second. So what is the probability that Apollo gets first and second? All right, so for probability, remember we think about the total outcomes. So we're going to have to find how many ways Apollo could get first and second. But then we're going to put it over our total ways. And how much is our total amount of ways for first, second, and third at the swim meet? 2,730. So whatever we get, we're going to put over 2,030. All right, for Apollo, how many Apollo swimmers are there to choose from? 5. So we're going to do NPR. There's 5 Apollo swimmers. And how many places are we wanting for those Apollo swimmers? 2. So 5, choose 2. Okay, since I already have this NPR here, I'm just going to be deleting it because that's just easier. So NPR 5, choose 2. And we get 20. So there's 20 ways that Apollo could get first and second place based on their 5 swimmers. So for probability, there's 20 ways where we get first and second out of 2,730 different ways total. Okay, if we simplify that, 20 over 2,730. As a fraction, we get 2 over 273. Okay, as a decimal, 0.007. So about what percent is 0.007? If you think about what's in the space, 2 spaces after the decimal would be 0. So 0%, or would we round up to 1%? 1, because the 0.7 would tell us to round up to 1. So about a 1% chance if it's random. Now, like we were talking about before, though, when you're swimming, is it just random who gets first, second, and third? No, it's based on ability, okay? Apollo has a really good swim team right now. So we probably would have a pretty good chance of maybe getting second and third. It's probably not too far off from 1% because Sartell has more swimmers swimming, so they're going to have better probability. But this is just if it was all random. All right, here we go with example number 2, last one. And then you have the rest of the time for practice. For number 2, we're going to think that we have an iPhone. Okay, on an iPhone, in order to unlock an iPhone, you need how many digits for a passcode? 4 or 6. We're going to go with our 4-digit passcode. Okay, now I'm creating a 4-digit passcode. When I put in a passcode into my phone to unlock it, does the order matter? Does it matter which order I put the digits in to unlock? Yeah. Okay, I can tell you guys right now, my passcode is made out of a 1, a 7, a 0, and an 8. Does that mean you guys know my passcode? Nope, you don't. Okay, you could guess it, but there's still going to be lots of ways to put that in. So you have to make sure that you are putting it in the correct order. Okay, today when we do our 4-digit passcode, we're going to do no repeats. Okay, when we about that no repeats or repeats. Okay, and I want to find the probability that if we randomly pick a passcode, we put all the digits into a hat, we pick out 4 digits, we randomly pick it, that the passcode starts with a 3-6. So the first two numbers in the passcode are 3-6. So in order to find probability, we need to find out how many options there are with a passcode starting with just a 3 and a 6. And then we also need to figure out how many total passcodes there are. Okay, I always like to start with our total passcodes. So I'm going to start with total. So we're going to do that permutation. How many digits are there to choose from? 10. Yeah, why are there 10 and not just 9? Yeah, 0. So when you look at this, anytime we count 0, we have to add 1 in. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, and then that 0 counts as the 10th number. So there's 10 to choose from. So we're going to do a 10. And how many are we picking for our passcode? 4. So for our total weighting about that 3 and 6, we're just thinking how many total passcodes could we do? Okay, so in our function, we'll go to that NPR, 10, 4, and we get 5,040. All right, now I want to think how many passcodes would start with a 3, 6. So when I do my choosing, my permutation, NPR, I already picked a 3 and a 6. So how many digits are left over to pick from? I need 2 more to fill in the 4, right? How many numbers do I have to choose from for these 2?
2.
For these last 2? Yeah, there'd be 8. So we started with 10 digits. We picked out a 3, picked out a 6. There's 8 left over. And how many spots left to fill? 2. So we're going to do 8, choose 2. All right, another way you might see this is just a 8, 2. Normally with a capital P, we think of probability, but if there's a comma in there, we know that then we're talking about a permutation. You're going to see that on your practice work today where it's just a P and then something, something. In that case, it doesn't stand for probability. It does stand for permutation. So 8, choose 2. 56, yep. How did you do that? Oh. Cool. All right, but we're going back to our idea of probability. So a probability that it starts with a 3, 6. How many different ways can we have a passcode that starts with 3, 6? 56 out of how many passcodes total? 5,040. Okay, so for these problems in your practice work, it's going to take you through kind of the steps of how to do it. It's going to go through like how many total there are, then how many for that specific situation. Okay, we get 0.01 repeating. All right, my first period class struggled a little bit to get this into a percent. So remember, for percent, we're looking at the hundredths place, because we're going to move it over 2 times. So which number is in the hundredths place? A 1, and if it's 1.1, should we keep it at 1 or round up to 2? 1, so about 1%. So it just so happens that in both of our examples today we got 1%. That's not a rule with permutations by any means, it just so happened coincidentally. All right, so that is your notes for today. All right, for part of your practice, it's going to